Okay, Bernoulli differential equations. First order ordinary differential equations in the form dy over dx plus p of x y is equal to q of x times y to the power n is called a Bernoulli equation. So what is the difference between linear and Bernoulli equation? So in linear one, we didn't have this y to the power n term. So recall that. So recall linear differential equations are of this form. Dy over dx, if you remember, it was p of x y is equal to q of x. So this was the linear differential equation. In Bernoulli, we have this extra term y to the power n, and we don't want n to be n is equal to 0 and n is equal to 1 cases are also linear cases. So if n is equal to 0, y to the power 0 is equal to 1, it is already linear, right? If n is equal to 1, and then we have qx times y, and we can send it to the other side, p of x minus q of xy we can write, and this is also linear, and it is also separable. We can separate y terms and x terms, and we can just integrate. And so how we solve Bernoulli differential equations? So they are very easy to solve because we can reduce this Bernoulli differential equation to a linear equation, and we can solve how we were solving linear differential equations, right? If you remember, in the previous lecture, we solved many linear differential equations by finding the integrating factor and multiplying and then integrating. And this, so how we will reduce this Bernoulli differential equations to a linear equation? We will use this transformation v is equal to y to the power 1 minus n, and we will get a linear differential equation in the variable v. But to do that, first we multiply the equation by y to the minus n, so that this we will get rid of this term y to the power n, because when we multiply y to the power minus n, we will get qx term in the other side only, and then we use this transformation to make it linear. Okay, let me solve an example. I think you will understand better. Okay, solve the following Bernoulli equation. Bernoulli equation, let's say dy over dx plus y is equal to x y cube. And here we have, if you remember, Bernoulli was dy over dx plus p of x y is equal to q of x y to the power n. Here we have p of x is equal to 1, q of x is equal to x, and what is n here? We have n is equal to 3. And we said that, okay, how we will solve? So first we multiply the equation by y to the power minus n. Or you can keep in mind that, okay, we want to make this part only q depends on q of x. So first multiply by y to the power minus 3 minus n, or let me write minus n. In this case it is minus 3, so we have y to the power minus 3 dy over dx. So we multiply every term. Y to the power minus 3 is equal to x times y to the power 3 times y to the power minus 3. And then we will substitute v is equal to y minus n. In this case we will have y minus 3, so we should have y to the power minus 2. So okay, let me just simplify this one first. So we have minus 2 is equal to x. So now let v, so v is equal to y to the power minus 2. So we will put v is equal to y to the power minus 2. But what about if we substitute this, what about dy over dx? So we will write everything in terms of v and x now. So we don't want to see y. So what we are going to do is, okay, let's take dv, the derivative of v with respect to x. So what is the derivative of y to the power minus u? Sorry, y to the power minus 2. So recall that when we have u to the power n, its derivative is n times u to the power n minus 1 times the derivative of inside, right? So this is the chain rule. And in this case the derivative is minus 2 times y to the power minus 2 minus 1 times y prime, so which is dy over dx. In this case we have minus 2 y cubed dy over dx is equal to dv over dx. So we have, oops. Okay, we will just substitute in the equation. Then, so, okay, let me write the equation again. dy over dx is equal to y to the power minus 2 is equal to x. And this part, so it is equal to, I'm sorry, and from here we have y cubed dy over dx is equal to minus 1 over 2 dv over dx, right? Okay, we will put instead of y cubed dy over dx, so we will put minus 2 dv over dx plus y to the power minus 2 is equal to v, and this is equal to x. So this is linear, but not in standard form. If you recall that standard form, we have the coefficient equal to 1, right? So standard form must be like this. I mean the coefficient of the coefficient must be equal to 1. But we can easily arrange like this. So dv over dx minus, so we multiply with minus 2. 2 is equal to minus 2x. Multiply by minus 2 to get the standard form. So in the standard form, this coefficient is always 1, equal to 1. Okay, then what we are going to do is we just solve using linear differential equations. What is the integrating factor? If you remember, integrating factor is e to the power px dx. So it is here minus 2 dx, and it is minus 2x plus c, but we take c is equal to 0. Okay, then multiply by the integrating factor, the equation with the integrating factor. Okay, let me write short as v prime minus 2 e to the power 2x v is equal to, don't forget to multiply the other side. And we said we will always get here, we have mu times v prime, we should have, right? The derivative of the product, which is, that's right, because the derivative of e to the power minus 2x is minus 2 times e to the power 2x times v, plus we have this, the other derivative. So the derivative of u v prime is u v prime plus u prime v. We have the derivative. and it is equal to minus 2x e to the power minus 2x. So to find v, we will integrate, we will just integrate, and this integral is, so we know that the integral of the derivative is itself f of x plus c, so that's why we have itself. What about the integral of this part? Oh my god, so I think we need to integrate using by parts, right? Oops. We need to, okay, integration by parts. We need to do integration by parts method, if you remember. Okay, let's do it in the other page. Okay, we will do integration by parts, but let's write minus 2 outside also. Minus 2x times e to the power minus 2x. So by parts methods, let's recall here. So how was it? It was u times dv is equal to u times v minus v du. Okay, what is here? X e to the power minus 2x dx. So here u is equal to x and r dv is equal to e to the power minus 2x dx is equal to dv. What is du? Du is equal to x. Oh, I've used the same notation. Sorry about that, because we have v here, but this is something different v, okay? So this is something we are different, doing something different from the example. Okay, let's integrate this to find v. It is minus 2x over minus 2 is equal to v. Okay, u times v minus v du, u times v, x times e to the power minus 2x over minus 2 minus 1 over minus 2 e to the power minus 2x times dx. So it is minus x over 2 e to the power minus 2x minus minus plus 1 over 2 e to the power minus 2x dx, and this is equal to, oh, this is a nice integral. I hope you know how to take the integral. Okay, there is plus c here. Okay, now we can put it back to in our equation. Okay, now, but as I said, this v is different from the, so this is the by parts method v. So now let's go back to our example. Okay, we take the integral. Okay, we will put this one in here, minus x over 2 e to the power minus 2x minus 1 over 4 e to the power minus 2x plus c. Oh, it is a nice one. Okay, I want to write it down because it will look ugly here there. Okay, sorry about that. Okay, let's simplify things. So we can, I think we can cancel all this e to the power minus 2x, right? But we shouldn't forget here. So v is equal to, so we divide by e to the power minus 2x. So we have v is equal to, and I will multiply everything with minus 2. So, okay, I have x plus 1 over 2 plus c times e to the power 2x. This is v, but don't forget v was y to the power minus 2, right? So this is the general solution. So finally we see some difficult integral, right? Great. So let's do one more example, and then I think we are done with Bernoulli equations. Okay, let's solve this one. Solve dy over dx plus y over 2x is equal to x over y cubed. Okay, this is a Bernoulli differential equation. We can write it like this: dy over dx 1 over 2xy is equal to x times y to the power minus 3. So here we have p of x, q of x, and n is equal to 3. So our p of x is equal to 1 over 2x, q of x is equal to x, and this time n is equal to minus 3. So we don't need to always have positive number, right? So we can have negative numbers also, minus 3. So what we are going to do is we will multiply. So multiply the equation by, if you remember, y to the power minus n. In this case, we will multiply with minus 3. So we will multiply with y to the power 3. Because our aim was to leave this term only q of x, right? So that's why we multiply with y to the power 3 times y to the power minus 3. We will get 1 here. So we will left with q of x term. To make it linear, we need to do such a trick. Okay, let me copy to the next page. We will continue to the next page. Okay, now we will multiply with y to the power 3. So y to the power 3 dy over dx plus 1 over 2x y times y to the power multiply 3. So we don't forget to multiply everywhere. And then let v to be 1 minus n. So it is 1 minus minus 3. So we will take v to be y to the power 4. And we will substitute v. So substitute v, and we need to also v prime. So what is v prime? It is 4 times y cubed times y prime. So recall that, recall how we take the derivative of u to the power n. It is n times u to the power n minus 1 times u prime. So the derivative of inside. Chain rule. So this is the chain rule. Okay. So what is dy over dx? here, or let's write y cubed y prime plus 1 over 2x y to the power 4 is equal to x. So what is y prime here? So y prime is equal to 1 over 4 y cubed v prime. So y cubed times 1 over 4 y cubed v prime plus 1 over 2x v is equal to x. So these will cancel. I will have 1 over 4 v prime plus 1 over 2x v is equal to x. So this is linear, but not in standard form. Okay, we can just multiply by 4. Multiply by 4 to make it in standard form. Okay, we multiply by 4. V prime plus 4 over 2x. It is 2 over x. V is equal to 4x. So don't forget to multiply everything with 4. Great, so this is linear. What is the integrating factor? Integrating factor is e to the power px dx. In this case, it is 2 over x dx. So now it is linear and in standard form. So what is the integrating factor? 2 ln x plus c, but we take c to be equal to 0, ln x squared, and this is equal to x squared. Now multiply by the integrating factor, mu is equal to x squared. Don't forget to multiply everywhere. 2 over x times x squared. V is equal to 4x times x squared. So we have x squared v is equal to 2xv 4x cubed, and this is the derivative of x times v, right, which is equal to 4x cubed. And to find v, we just integrate, so this is x squared times v is equal to 4x to the power 4 over 4 plus c. So v is equal to x4 plus c. But if you leave it like this, you will get minus 5 points, because what is v? You need to substitute v back. So v was y to the power 4. So don't forget to substitute v back. So y to the power 4 is x to the power plus c is the general solution of the differential equation. Oh, I forgot to write x squared. Sorry about that. So we had x squared v, right? Sorry about that. X squared y4 is equal to, so this is the general solution of the Bernoulli differential equation. You can divide everywhere with x squared also, x squared plus c over x squared, or you can write it like this, c times x to the power minus 4, sorry, minus 2 also. So this is also okay. This I mean, it is enough for me to see this one to give you a full point. But if you leave it here, you will get minus 5 points. So here you will get the full point. Okay, minus 5 is too much, maybe minus 2. Okay, I think this is the end of our this lecture, and this week we have the Halloween, I think, right? No, Halloween was last week. Sorry about that. This is lecture 9, I think. Yeah, sorry, it was last week.